Hello students, I am Dr. Neera Sharma. Today I bring you a learning episode in BSc Forensic Science on behalf of the content writers Dr. Vimal Rar and myself on an important unit which is overview of explosives, that is explosives part 1, in which we will discuss about the classification of explosives and type of explosive, as well as you will be made acquainted with the knowledge of shipping labels, classification of explosives and properties of explosive materials. We will wind up this episode with an explosive regulation in India. So, let us start our episode with a look at what we are going to learn today. So, we will start with the introduction, then overview of explosives, classification of explosive, types of explosives, their shipping label, classification of explosives, properties of explosive materials, explosive regulation of India, and finally, we will conclude the module. In the simplest terms, an explosive is defined as a substance which on initiation by shock, impact, friction, spark, flame, heating or any simple application of an energy pulse undergo a prompt chemical reaction, progressing a large expanse of heat and exerting a high pressure on its surroundings. It has been used in blasting and quarrying, have permitted the erection of transportation, contacts, provided the rock and raw ingredients for construction and empowered the wide-ranging mining of minerals and other essential materials. Explosives are applied lawfully in engineering and in military, but also get used unlawfully in radical and felonious activities. Certain explosive compounds have other applications like in medication or in paint industries. Military and industrialized explosives are characteristically analyzed after their manufacturing for quality control. The analysis includes qualitative investigation. The examination generally consists of quantification of explosives, byproducts and contaminations in way to meet acknowledged conditions. Additional regions which work with the examination of explosives are forensic science, environment analysis and in many cases toxicology as well as forensic examination of explosives related with the recognition of non-reactive explosives along with post-explosion recognition. The identification of an unexploded explosive is carried out to substantiate its possessions of its projected use. The rapidity of explosion is one of the limitations applied to categorize an explosive. The other key constraint is whether or not a usual detonator can cause the explosion. Explosives, propellants and pyrotechniques belong to a comprehensive group of compounds and compositions known as energetic materials. All explosives can be classified as either low or high explosives. Low explosives, also called as propellants, while still containing the oxygen needed for their burning, are at most combustible materials which undergo deflagration by a mechanism of surface burning. Low explosives can still explode under the confinement, but this is a consequence of the increase in pressure produced by the release of gaseous products. Some low explosives can also detonate under confinement if originated by the shock wave of another explosive. Low explosives include substances like gunpowder, smokeless powder and gun propellants. High explosives on the other side need no confinement for explosion. Their chemical reactions are far more rapid and undergo the physical phenomenon of detonation. In these materials, the chemical reaction tracks a high pressure shock wave which propagates the reaction as it moves through the explosive substance. Another means to categorize an explosive is how sensitive it is to a mechanical or thermal stimuli. The sensitivity of explosive to stimuli is a broad spectrum, but those explosives that readily explode from light to modest mechanical stimuli are designated as primary explosives, while those explosives which need the shock wave of an explosion or a high energy impulse are called secondary explosives or simply high explosives. Section 21D of Explosives Act, developed in 1884, defines explosives. It says that explosives indicate gunpowder, nitroglycerin, nitroglycol, gun cotton, dinitrotoluene, trinitrotoluene, picric acid, dinitrophenol, trinitroresorcinol, cyclotrimethylene nitramine, pentaerythritol, tetranitrate, tetryl, nitroguanidine, lead azide, lead stiffnate, fulminate of mercury or any additional metal, diazodinitrophenol, colored fires or any further substance, whether a particular chemical complex or a combination of elements, whether solid or liquid or gaseous, applied or man-made, with a vision to yield a real world result by explosion or pyrotechnic effect, and comprises fog signals, explosives, fuses, missiles, hitting caps, detonators, casings, ammunition of all accounts and every version or groundwork of an explosive as well as well defined in this clause. Scientifically, an explosive is a material which when correctly instigated is promptly transformed to fumes at high temperature and pressure. This process is known as detonation. More precisely, an explosive material is a solid or liquid substance or a combination of elements which is in itself proficient by chemical reaction of generating gas in given temperature and pressure and at a given rapidity as to root destruction to the environments. Controversially, it may not appropriate to describe an explosive as a substance or a combination of material which is able of undergoing a sudden transformation with the releasing of heat and gas. The formation of heat unaided by the inborn energy of the material that generates it will be sufficient to establish the constituent of an explosive. All explosive substances generate heat and approximately all of them form gas. The variation is consistently supplemented by the release of energy. The resultant of the blast symbolizes a lower energy range comparative to the explosive before it has caused the blast. An explosive perfectly able of causing a blast may liberate its energy without producing one. An explosion may occur without an explosive, that is, without any material which comprises intrinsically the energy needed to produce the explosion. Explosives generally need some stimulus, such as shock or a stimulus, to incite them to release their energy, that is, to experience the variation which generates the explosion. But the motivation which sets off the explosive will not responsible to the energy of the explosion. The number of stimuli to that explosives return and the mean of their reaction in creating explosions delivered an appropriate foundation for the reorganization of these interesting materials. Pyrotechnic substances are encompassed even when they do not progress gases. An explosive cannot be said as a very explosive substance merely because of its after effects. It must be shown whether it is sensitive to fire or to shock, or whether it is really powerful or merely present, or both. or whether it is fast or slow. Its sensitivity, stability and reactivity should be distinguished cautiously. A material may be exceptionally responsive chemically but completely constant in the non-existence of whatever with which it counter. A material may be detonated voluntarily or by a minor shock wave, but it may be unchanging if left to itself. Another may need the shock wave of a prevailing detonator to make it explode, but may be subject to spontaneous decomposition. Standardized testing evaluates the sensitivity in respect of friction, impact, heat, shock. Depending on these results, explosives are classified accordingly. Broadly, explosives can be categorized into two categories. They are as follows. The first one is low explosives. Low explosives or propellants are combustible materials comprising inside themselves all oxygen necessitating for their burning, which heat but will not detonate and produces gases that generates an explosion. Low explosive deflagrate in comparison to detonation. Their reaction speeds are 2000 to less than 3000 feet per second. Black powder is a good example. These materials normally have little water resistance and are highly flammable. Low explosives usually do not fragment rock like high explosives. It is probable for them to deflagrate very swiftly, generating an influence alike to a detonation. This typically happens when ignited in a confined space. Explosives of this category vary extensively amongst themselves in the rate at which they distribute their energy. There are slow and fast powders for various applications. For example, black powder and smokeless powder. Now we will see high explosives. High explosives explode in the presence of the shock wave of the detonation of an appropriate primary explosive. They do not carry out work by burning. On contrary, not all of them are flammable, but maximum of these can be exploded by a spark and in insignificant quantity, normally burn quietly and can be switched off effortlessly. If excited to a higher temperature by external warmness or by their own combustion, they sometimes explode. They fluctuate from chief explosives in not being detonated freely by warmth or by shock and generally being more powerful. They apply a power-driven influence upon all that is close to them when they detonate, whether they are confined or not. An extraordinary explosive is some chemical mixture that explodes with a response velocity over 5000 feet per second. Examples consist of dynamite, trinitrotoluene, tetryl, picric acid, nitrocellulose, nitroglycerine, liquid oxygen varied with wood blend, fuming nitric acid combined with nitrobenzene, compacted acetylene and cyanogen, ammonium nitrate and perchlorate nitroguanidine. High explosives are classified into primary, secondary and tertiary explosives as per its level of response to exterior stimuli. Now we will know about the primary high explosives. The primary high explosives are enormously sensitive to mechanical shock wave, resistance and temperature, to which they will return by scorching swiftly or exploding. Secondary high explosives. They are also known as base explosives. They are comparatively unaffected to shock wave, resistance and temperature. They may burn when wide open to heat or spark in insignificant liberated measures, but explosion can happen. These are occasionally kept in lesser quantities to attacking caps to enhance their influence. Now, we will come to tertiary high explosive. These are unaffected to shock wave. They cannot be consistently exploded with real world quantities of primary explosive, and as an alternative need an in-between explosive promoter of secondary explosive. For example, ammonium nitrate or fuel oil mixture and slurry explosives that are primarily applied in large scale mining and constructions. Apart from the classification based on the degree of explosions, as discussed earlier, explosives have been categorized in different other classes according to various criteria. Explosives also has been categorized as per to their elemental structure. The most important class includes organic compounds which comprise the nitro group. They are subdivided rendering to the atom to which the nitro group is attached. Nitro compounds contains CNO group, nitrate esters that is CONO2 group and nitramines that is CnNO2 group. Another classification could be military and industrial explosives established on the application for which an explosive is designed. These two classes are distinguished by the law implementation agencies. A third one, which includes homemade explosives, popularly known as improvised explosives. Historically, black powder was one of the primary explosives to be energetically analyzed from a chemical viewpoint. A combination of potassium nitrate, charcoal and sulfur black powder suffers an extremely sensitive burning, which yields great amount of heat and gas in the process. The application of charcoal, though generates abundant quantities of smoke in the procedure, creating black powder, an integrally disordered explosive. Smokeless powder rapidly verified as harmless, less disorganized substitute to black powder as an explosive. By 1840s, two predominantly capable smokeless chemicals were revealed, nitroglycerin and nitrocellulose. Colloquially known as gun cotton, nitrocellulose was first produced. Now we will see the industrial explosives. As the name suggests, industrial explosives are applied for the bona fide purposes for the well-being of general public. Industrialized explosives are also called as commercial explosives. They are used for legal excavating, process inquiries, rock digging, construction, blasting, river engineering and other processes. Are high explosives which are guided by the expert to produce controlled explosion in way to demolish specific target and to further avert collateral damage. ANFO blasting gelatin, dynamite stands amongst the main examples of industrial explosives. Now we will see military explosives. These are those categories of explosives which are exclusively used for combat purposes, contrary to the industrial explosives, which are generally more like guided explosives. Armed explosives are accomplished of generating instant destruction in all possible direction of detonation. Examples of armed explosives are PETN, RDX, HMX, etc. There is a debate that whether atomic explosives could be categorized under the military explosives or not. The answer eventually rests on the usage of such explosions. An atomic explosion for scientific purposes will not be harmful to the society, deviating it from the military usage. But if the same is used for mass destruction or taking human lives, it will definitely lie below this category of military explosives. Now we move on to improvised Explosives. Improvised explosives have an extensive variety of meaning, encompassing modified devices containing commonly available explosive substances or a device so transformed that it could origin explosion which normally would have not. A chemical may not show explosive nature, but by little modification, it can form a lethal explosive. The improvised explosive device, termed as IED, is used by insurgents, terrorists and criminals around the world due to its ease of manufacture, relatively low cost and potentially devastating effect on the people and property. The specification relating to explosive transportation depend mainly on the type and amount of explosive. Explosives, by their very definition, are potentially unstable compounds. They will decline if unprotected to inappropriate situation like as heat or humidity. Dissimilar kinds of explosives have a fluctuating shelf life, subject to how they are stored and used. The approval and licensing of magazine is subject to state and territory regulations. All dangerous goods are formally classified by statutory authorities, conferring to the main type of risk that they present. The labeling of explosives includes marking on the external protective material, marking on the inner packing, marking on the covering, diagrams upon the package. Diagrams may display the nature of substances and they may be explosives, flammable, spontaneously combustible, dangerous when wet, oxidizing agent, toxic, corrosive, miscellaneous dangerous goods. All explosive compounds mainly consist of three constituents, namely fuel, oxidizer and sensitizer. Carbon, hydrogen, sulfur, etc. deliver the essential fuel for the oxygen in oxidizer. Combination of a chemical or physical sensitizer improves the handling with which the explosive can be formed to react by means of an initiator. The molecular explosives like nitroglycerin or TNT do not involve a sensitizer, whereas others may require such components in way to attain a degree of sensitivity that is practical from a blasting point of view. Explosive reactions are exothermic and impulsive, producing of a significant quantity of heat and is self-sustaining once originated. Explosions also discharge a significant quantity of gas very rapidly. The positions of explosives are studied by the following parameters. 1. The detonation velocity. As it is known that explosive is a substance which when properly initiated is very rapidly converted to gases at high temperature and pressure, and this process is called detonation. Detonation velocity generally defines the degree of explosion which results from an explosion. The detonation velocity or the speed of detonation is one of the parameters used to classify an explosive. The velocity of detonation, termed as VOD, is the rate at which the detonation wave travels along an explosive column. The greater the velocity of detonation, the greater the power or shattering effect of an explosive. Number 2 is density. Density is an important consideration when choosing an explosive. For difficult blasting conditions or where fine fragmentation is required, a dense explosive is usually necessary. The density of an explosive may be expressed in terms of specific gravity. Specific gravity is the ratio of the density of explosive to the density of water under standard condition. Number third is detonation pressure. Detonation pressure is a function of the explosion velocity and compactness of an explosive. The explosion pressure is more dependent on explosion velocity than specific gravity. It is basically the compression in the reaction zone as an explosive explodes. It is a noteworthy pointer of the capability of an explosive to generate good disintegration. A extraordinary detonation pressure is one of the desired feature in a primer. Now the fourth one is water resistance. An explosive's water resistance is a degree of its capability to endure experience to water deprived of declining or trailing sensitivity. Sensitivity is the easiness by which an explosive explodes. In dry work, water resistance has no consequence. In general, gelatins and emulsions offer the best water resistance. Higher density explosives have reasonable to outstanding water resistance, while low density explosives and exploding agents has slight or none. The fifth one is fume class. Preferably explosion of a marketable explosive produces water vapor, carbon dioxide and nitrogen. In addition, undesirable poisonous gases such as carbon monoxide and nitrogen oxides are usually formed. These gases are called as fumes, and the fume category of an explosive specifies the nature and the extent of unwanted gases designed through the explosion. Now the sixth one is sensitivity. It is a degree of the ease with which an explosive can be exploded by heat, resistance or shock wave and of its capability to spread that detonation. Contemporary commercial explosives can be assembled into two chief classes rendering to their sensitivity detonator, sensitivity explosives and attacking agents. Some explosives with very great sensitivity like as pure nitroglycerin or dynamite can be exploded by mechanical impact or friction. In India, management of explosives are strictly governed by the Explosives Act, developed in 1884. This act was promulgated to control the production, possession, usage, sale of explosives. Later, with the amendment, transportation, importation and trade of explosives were also taken under control of this act. According to this act, it requires license to compact with explosives and that too with stringent rules and regulations. Even pyrotechnics are controlled by this act. Apart from the Explosives Act, in 1884, the time to time released explosive rules control the dealing with explosives. License is required to store detonators and explosives. The license is subject to the assembly and location of the offered depository being granted approval. There are guidelines prevailing process comprising isolated storing of explosion and keeping of records. Ammonium nitrate and unpackaged emulsions are comparatively harmless until mixed with a sensitizer. They are also used in very large quantities. Construction of storage facilities is therefore themed to less rigorous regulations conferring to the production, storing and importation of dangerous chemical rules. Under the Schedule 3, explosive substances are mentioned as Group 4. Explosives have involved a lot of undesirable promotional over the years for their abuse in taking of life and devastation of property. Explosives are apparent by maximum as resources of fear, and at no period is this additional widespread than in eras of conflict. Though these concerns or interpretations are not unfounded, there is a bigger picture. More detonations have been applied in intervals of ceasefires than in wars and conflicts put together. An explosive can be defined generally as a store of energy that can be made to release that energy in a manner as to do work. Explosives may be classified according to their chemical structure, use, their place in the detonation chain, and their explosive properties. Despite their initial designation as explosives, many of these molecules have carried on to fulfill much greater and more diverse roles. Explosive molecules obey the same chemical rules and physical rules as any other molecule or compound, and many have the potential to create positive effects beyond the realm of explosive chemistry. Progresses in machinery aims for even more demanding applications. Research in explosive technologies is profoundly concentrated on the schemes and production of explosives for particular uses. Explosives of high thermal constancy and those with a low sensitivity to influence or friction are particularly desirable. Dear students, I hope you have enjoyed the study content of this episode. Terrorist attacks are often seen and are major threat to the society. Bomb blasts are their main weapon to disseminate fear. A forensic scientist is frequently encountered with the task to examine the substance which is suspected to be an explosive, or by this way investigating agencies are assisted to combat with terrorism. I believe this topic would create an interest within you to learn more about the explosives.